The Holocene epoch. It sounds like a distant era, lost to the mists of time, but it is not. It is our time. It is the epoch that began with the end of the last ice age, roughly 11,700 years ago. It is the epoch that cradled the rise of human civilization, and it is the epoch that is now coming to an end. We are living through a time of unprecedented change. Our planet is warming, the ice caps are melting, and sea levels are rising. The very fabric of our biosphere is unraveling. This is the sixth mass extinction event in Earth's history, and we, the human race, while not directly responsible for mass extinctions, may be able to mitigate some of the disasters that may happen in the future. But amidst the despair, there is hope. We can choose to build a sustainable future for ourselves and for generations to come. The Holocene may be ending, but our story is not over yet. We have the power to write the next chapter. Am I the only one that didn't know stars? Those celestial fireballs that illuminate the cosmos may seem eternal, but they are not. Like everything else in the universe, stars have a lifespan. They are born, they live, and they die. A star is born from a collapsing cloud of gas and dust. Gravity pulls the material inward, squeezing it tighter and tighter. The temperature and pressure at the core increase until finally nuclear fusion ignites. Hydrogen atoms fuse together to form helium, releasing a tremendous amount of energy in the process. This energy pushes outward, balancing the inward pull of gravity. The star is now in equilibrium, shining brightly for millions or even billions of years, but the star's fuel supply is not infinite. Eventually, the hydrogen in the core is exhausted. The core contracts, heats up, and eventually ignites the fusion of helium into heavier elements. The outer layers of the star expand and cool, transforming it into a red giant. For stars like our Sun, this expansion will engulf the inner planets, including Earth. Eventually, even the helium fuel runs out. The outer layers of the star are blown away, forming a beautiful planetary nebula. The core, now a white-hot ember known as a white dwarf, slowly cools and fades over billions of years. If you are enjoying the video, please like, share, and subscribe. It will help the channel tremendously. Thank you. We often think of matter as being permanent, unchanging, but even matter itself may not be eternal. According to some theories in particle physics, the very building blocks of matter, such as protons, may be susceptible to decay. Protons are subatomic particles that, along with neutrons, make up the nucleus of an atom. They are incredibly stable, with a lifespan far exceeding the current age of the universe. However, some theories predict that protons can decay into lighter particles, such as positrons and pions. If proton decay does occur, it would have profound implications for the fate of the universe. Over vast stretches of time, all matter, from stars and planets to black holes, would eventually dissolve into a sea of subatomic particles. The universe would become a thin, diffuse soup of radiation and elementary particles. The universe is expanding. This has been known since the 1920s, when astronomer Edwin Hubble observed that distant galaxies are moving away from us. What is driving this expansion? The answer, it turns out, is one of the biggest mysteries in modern cosmology: dark energy. Dark energy is a hypothetical form of energy that permeates all of space. It is thought to be responsible for the observed, accelerated expansion of the universe. Unlike gravity, which pulls things together, dark energy pushes things apart. The nature of dark energy is still unknown. Some theories suggest that it is a property of space itself, a kind of cosmological constant that has been present since the Big Bang. Others propose that it is a dynamic field, evolving over time. Whatever its nature, dark energy has profound implications for the fate of the universe. If it continues to dominate the expansion, as current observations suggest, the universe will continue to expand forever. Galaxies will become increasingly isolated from one another, eventually fading from view. the heat death of the universe. As the universe expands and cools, it will eventually reach a state of maximum entropy known as heat death. This is not a fiery inferno, but rather a slow, gradual decline into darkness and stillness. Entropy is a measure of disorder or randomness in a system. The more entropy a system has, the less organized it is. The second law of thermodynamics dictates that the entropy of a closed system, such as the universe, can only increase over time. In the far distant future, all stars will have burned out, leaving behind only cold, dark remnants. Black holes will have evaporated through Hawking radiation, a slow process by which black holes lose mass over time. The universe will become a cold, dark, and empty place, with all matter and energy evenly distributed. Gravitational waves, echoes of cosmic cataclysms. Imagine a pond, its surface smooth and still. Now, imagine a pebble being dropped into the pond, creating ripples that spread outward. These ripples are analogous to gravitational waves, disturbances in the fabric of space-time itself. Gravitational waves are produced by the acceleration of massive objects, such as black holes and neutron stars. When these objects collide or orbit each other closely, they create ripples in space-time that propagate at the speed of light. The first direct detection of gravitational waves was made in 2015 by the Laser Interferometer Gravitational Wave Observatory, or LIGO. This groundbreaking discovery opened up a new window into the universe, allowing us to study some of the most violent and energetic events in the cosmos. A glimmer of hope. The potential for rebirth in a dying universe, the heat death of the universe, may seem like a bleak and inevitable end. But even in the face of such cosmic despair, there is a glimmer of hope. Some theories suggest that the universe may not end in a whimper, but rather in a bang. One such theory is the idea of a cyclical universe, in which the Big Bang is not a singular event, but rather one in an infinite series of expansions and contractions. In this scenario, the universe would eventually collapse back in on itself, only to rebound in another Big Bang. Another possibility is that our universe is just one of many in a vast multiverse. In this scenario, new universes could be constantly forming, perhaps even as a result of quantum fluctuations in the vacuum of space. The multiverse, a tapestry of infinite possibilities. The concept of the multiverse is one of the most mind-boggling ideas in modern cosmology. It suggests that our universe, vast as it is just one of an infinite number of universes, each with its own unique set of physical laws and properties. There are many different models of the multiverse, each with its own set of theoretical underpinnings. Some models propose that new universes are created through quantum fluctuations, while others suggest that they are born from the collapse of black holes. The multiverse remains a highly speculative idea with no direct observational evidence to support it. However, it is a tantalizing possibility that captures the imagination and pushes the boundaries of our understanding of the cosmos. Our place in the grand scheme of the cosmos. We have journeyed from the familiar realm of our own planet to the farthest reaches of the cosmos, exploring the life cycle of stars, the fate of matter, and the ultimate destiny of the universe itself. We have contemplated the possibility of proton decay, the expansion of the universe driven by dark energy, and the eventual heat death of all things. Yet even in the face of such cosmic grandeur and ultimate demise, we find ourselves filled with a sense of awe and wonder. For we are part of this universe, connected to it in ways we are only beginning to understand. The very atoms in our bodies were forged in the hearts of stars, and the energy that sustains us comes from the fusion reactions that power the sun. As we continue to explore the cosmos and unravel its mysteries, we gain a deeper appreciation for our place in the grand scheme of things. We are but a small part of a vast and ancient universe, yet we are capable of comprehending its wonders and marveling at its beauty. And even though the universe may have an end, our quest to understand it will continue, driven by the insatiable curiosity that defines our species. If you enjoyed this video, please like, share and subscribe to the channel so I can bring you more exciting content. Thanks for watching.